Welcome to Data Cleaning with Python course. During this course, we are going to cover the most fundamental step when it comes to dealing with data. This step is data cleaning, and it usually comes after you have explored your dataset. So once you get a dataset, normally what we do is we first of all read it or load it. Then later we explore the dataset, just understanding the structure that could be fetching for one particular record and understanding it. Then you could later onwards also exploit by having a look at the data types, also the shape, etc. So this step this step of data cleaning usually comes in after you have understood your dataset. And in this particular course, we are going to cover some of the most fundamental techniques that you need to perform in order to clean your dataset. So the learning outcomes for this course are as follows. I can standardize a dataset by fixing inconsistent column names. I can perform data type conversion to fix inaccurate data. I can find and fix syntax errors in a dataset. I can find and fix typos in a dataset. I can deal with irrelevant data in a dataset. I can remove any duplicate records in a dataset. I can find and deal with missing data in a dataset, and I can find and deal with outliers in a dataset. The motivation behind this course is because once you start working with the dataset and you would need to, say, create a model or perform a certain analysis, maybe create visualizations, you would have to, first of all, while creating, say, a model, have to consider whether your dataset is cleaned, because if your dataset is not cleaned, it would mean that your model might end up predicting some input data incorrectly. So ideally what you need to do is make some decisions about the aspects of your dataset that is inconsistent. So maybe there are outliers, so you need to deal with those ones. So, or if there's missing data, you need to figure out how you go about missing data, and you perform a procedure. Then afterwards, you say perform your analysis. So once again, you could always reach me via the following email, and we could always connect through LinkedIn so that you can be able to get updated on future courses that may arise. Alright, so let's get started. Alright, so in this section we are going to cover the first learning outcome, which is I can standardize a dataset by fixing inconsistent column names. So let's open our notebook. First, in order to start working on this notebook, we need to load these two libraries, pandas and numpy. Then we can go through the examples, which will show us how to do this that we have set out to do, which is standardizing a dataset by fixing inconsistent column names. So for the first example, we first of all load our dataset, the dataset that we'll need, and immediately we can see that the dataset has a bit of some inconsistencies. So you can see the column names are capitalized. One of the column values, the values are not, they're different. Some of them are capital, some of them are lowercase. You can see the same here. We have something of this sort, some spelling error. We have height of 56, which is quite short. Maybe this is in a different format. So, and the weight is quite large. It could be in a different format. Could see missing values. So ideally what we're going to do here in this session is to just standardize our column names. And the first example, the first aspect that we're going to cover is renaming the column names. And if you wanted to rename these column names into more readable and values that we can easily handle, what we would do is replace those column names, as we can see these column names, by the column or by the values that we want. So in this case, we have all these values that we would like to replace to have as our column names, and this is how we would do. Just ideally we would have a list, then put those column names, new column names, then assign them to our data frame. So if we do this, this is what we see. So we have our new column names. Alternatively, we could suppose you had 100 column names. So alternatively, what we would do, doing this would be cumbersome. So what we would do is, let's first of all create a new data frame and load our original data set. So what we would do is use these functions: strip, lower, replace. There are actually many of them. If you go to the pandas documentation, you'll find a ton of, well, not a ton, but many functions which you can be able to use in order to manipulate your column names. So in our case here, this is just a simple example, but you could always figure out how you can be able to customize to your case. So in our case over here, we would refer to our columns, then we would refer to our functions as well, the functions that we would want. So this function, as you can see, strip, as shown, it removes leading and trailing characters, so at the beginning and at the very end. So it removes all of those. Then this lower function would lowercase all the values within our the values that we want. This same case with replace, it would replace any space with an underscore and replace any left bracket character with nothing, the same right with nothing. So in our case, we don't have these two, so we can remove these ones. So if we were to run this, we should expect the same result as this. So if we run it, we should expect the same, similar example is the same. So which we have really neat column names that we can be able to refer to. All right, so moving to the second example, this example asks us to convert city column. This is a city column to lowercase. So in our case, we would want to convert Lisbon and London into lowercase and probably other values within the city column. There could be maybe hundreds of thousands or even tens of thousands. So we cannot be able to go through one by one doing that. So we just also use the lower function from this particular documentation. It's just as easy as that. Just use this, refer to the city column. As you can see here, we do not refer it with the old unneat column name. We use the new one, and we replace now the values of city of this city column with the new lowercase column names. Then we can preview that and see what happens. You can see our city column has now neater values that we can be able to use. Okay, moving on to a third example. So in this example, we are required to convert our height into centimeters. So apparently this is in inches, 56 centimeters. If initially we were to look with at this data set without any glossary, we wouldn't be able to understand the data set really well. But in our case, assuming that this was in inches, so this is how we would be able to convert it to centimeters. So we just multiply by 2.54. Almost as similar as what we did here. So we our outcome in this particular example is that we are going to get the current height column, and multiply those values by 2.54, and they should give us the new values, the new height in centimeters. Then that list of heights, we would assign it back to, we would replace it, we would replace the old values with the new values. So it's more like assign these values to this particular column. And as we would be able to see, if we run that, we can be able to see the height of 156. This is actually the correct height. Okay, we can determine our data types, and we can see what we can study our data, and you can see what happens. And in our case here, assuming that we've been asked also to perform another conversion of a data type conversion, and we have been asked to convert this height, you can see height to integers, so to the int data type. So we could just use this apply function and provide now the new data type conversion that we would want. So in our case, we would convert all these values, then they are all numerical, these ones, into now integers, and our result should be just integers. So here it would be 142, here 157, etc. Well, this just tells us that the height has been converted, but what happens if we just preview our new data set, df.head, we should be able to see what happened, as you can see here. So our new height column has been converted into integers, which is a good number to work with. Normally you don't say that I am 170.25 centimeters now. You just say, maybe I'm 1 meter, 1.49. That's my height. All right, so let's get started with the challenges, and we have also provided solutions which can be found within the resources section as well. All right, see you in the next video. Okay, so in the previous video we covered two learning outcomes, the first two. Now in this section we are going to cover this third learning outcome. I can find and fix syntax errors in a dataset, as well as I can find and fix typos in a dataset. So let's open our notebook. First of all, what we do is normally we load the prerequisite, and that is the pandas library. It usually takes a few seconds to load. So the first example, now going through the first example. In this particular example, we are required to replace Germany with Germany. So there's, assuming that we had a few typos within our data set, so we would be able to do that easily by doing what we will do in this first example. Let's first load our data set so that we can see how it looks like. Okay, so we have our data set here. And we can see we understand the data set. So assuming that we have been asked to replace Germany with the correct one, how we would go about it is through also the use of the replace function, and we would specify the value or the string that we would want to replace within the country column. So we have already specified our country column. So this particular action would replace all texts or strings which look like this, and they would replace it with this particular string. So if we run this, we should see, even from just the head, this particular change. As you can see, this is Germany, which has been replaced, and if you are able to see the entire data set, and there are different old Germany values, they would also be replaced by this new value. So going through the second example, what happens if we wanted to strip the leading and trailing spaces? So these spaces normally are within data sets. Sometimes you could have this, like in this case, you have some space at the very beginning and some space at the very end within our data set. So let's first of all observe our leading and trailing data spaces within this city column, just to get a good understanding of what these spaces are. So technically, as you can see, so here there's some space over here at the very beginning. There's some more space here, there's some more space here, there's space here. This could be fine, but you never know, this could be fine. So when we load our data frame, presents the data like, it's fine. But what happens if we were to export that data frame? What happens is that it would also export the trailing and leading spaces. So we are going to remove this space and also remove these spaces. And how we're going to do that is using the strip function, and this function will help to remove both the leading and trailing spaces within the city column. And you can see we now have a good looking column. So we could always do that for the rest of the data frame. All right, this is just by the way, it's just an example that we put it out there. It's not common that you would be going through this scenario. Sometimes you might be asked to add pad strings, which are just strings after a particular position within that you specify within, let's say, the string. And a good example would be assuming that we wanted to have, let's say, stock, then ... Brussels ... Berlin or Bal ... How do you do that? So this is how you do it. First of all, usually remove the null values in order to avoid errors while adding padding. Assuming that you just have a null value, then it's not going to help. It's the idea is that you have some value that you can be able to append the string to. So you remove those null values, and then the next step, you would now add white spaces to the left side. So it's well, not really add, but it's you specify where exactly you'd want to add now the pad string that you want. So our pad string would be this. So assuming that we were to run this, so this is name, so it would be referring to the first. So this is name, so we would be referring to our city. Okay, well, we could always let's just use the first one, sorry about that. Name, and we wanted to add a pad string. Let's see what happens. So as you can see, so we were able to add pad strings within our our strings at the very end. It's not a common method that you can be a technique that you apply in datasets, but it's just something that you could always have in mind. All right, let's move on to our now challenges, which are at the bottom, and these ones can be found in the resources section. In this session, we are going to cover the learning outcome, this fifth learning outcome. I can deal with irrelevant data in a dataset. So let's go to our practice notebook and run our prerequisites and now go through the examples. Before we even go through the examples, assuming that we have been given a research question that only requires only a subset of our dataset, if we needed to answer our research question with only just a subset of our dataset, what do we do with the rest of the dataset? The common technique or method or the action that is usually applied is just to drop the rest of the columns, because you're not going to need all those other columns or variables for your analysis. The goal is to answer the research question. So in this case, we would delete any irrelevant column. So first of all, we are going to load or run our cell, and here we have our data set, and we have been told we need to delete our irrelevant data set. Let's first of all find the shape of our data set. 88. It's not a lot, it's just for example purposes. So you have been requested to delete the city column, and we would do this in the following manner. So we would first of all use the drop function, and we would be able to pass these parameters. So the first one is for specifying which particular column that we want to drop. Then we would specify the axis to 1, and when we set the axis to 1, this would represent the columns. So axis 0 represents rows and axis 1 represent columns. So axis 1 is what we want. So we want to delete this particular column, and then in place we would also assign in places true, and the meaning of in place being true, it would mean that the changes would be made in our original data frame. So if we were to do this, the changes would be made here, but if you do not specify this, then it wouldn't be able to, the changes would not be affected in our data frame. So running this should drop our city. As you can see, we have dropped it, our city column. Okay, we can also drop multiple columns as shown below, so we just have to specify the ones that we want as shown. What if we had in record or cross dataset errors? So these are errors that arise assuming that we have two columns, A and B, which amount to, they sum to, total account. How do we go about identifying columns which have wrong data? So it could be that this one has missing data. So how do we deal with this value? But because we have this value, which is the sum of this and this, then we can be able to find this particular value. But sometimes you might have these two missing values, and account A and account B amounting to this. Then what do? You would if for example, if your research question does not require these two, then you could always drop these two. But if it does require these two columns, then it means that you would not be able to have values for this particular record, which sometimes that would mean that this record may not be of use. So let's first of all deal with this particular problem. We would want to check whether total account, this particular total account amounts to these two. So first of all, we load our dataset, but what we have done here, we have created another column. So what we did is we created another column which is a sum of A and B. So we created another column, total count 2, which is a sum of this and this. Then we created another column to tell us whether if these two columns match, and if these two columns match, then this particular new column would tell us true or false. This is what this particular line of code does. It just checks whether these two particular columns or the values in these two columns match. Then it assigns whether it's true or false. As you can see, this is what it has done. So these two match, these two match, these do not, these do not, these do match. So you can be able to see what you can be able to do with this. So as I had mentioned, you can be able to do this. You could either correct the values. You could specify, let's say, column. You could specify column A plus column B is equals to column, see or total account, or you could even drop and delete the values, or even decide to leave them as they are, maybe because those values would not affect your analysis. And maybe the research question might also have there could be a question that asks how many values have inconsistent, how many inconsistent values are there within your data set, or something of the sort. And again, if we had a large data set, we could just get the number of records using the length, and this would help us in the decision-making process. Maybe there are a few missing values, there are few records with missing values, so you could just delete those records, and they might not necessarily impact your analysis. But this is just a way if you wanted to know how many of these values do not match the ones that are false. So how many do not match? How many of falses do we have here? Like how many records do not match, do not have total account A and this total account 2 matching? All right, let's go through now the challenges, and also we'll have a look at the solutions later onwards. We will now go through the 6th learning outcome, and this is I can remove any duplicate records in a dataset. Now going to our practice notebook and running the first line of code, the prerequisites, then going through the examples. Assuming that we had a dataset and the dataset had duplicate records, what we normally do is you just delete those repeated records because they do not add any meaning within your dataset, not unless those records are intentional, or are not even intentional, but not unless those records happen as are as a result of a natural phenomena. Maybe it could happen that those records are similar majorly because that is how the system that they were recorded in behaved at that particular point in time. So it could be maybe in a particular city, the temperature, average temperature was similar for a period of, let's say, 3, 4, 5 days. That's fine. You could keep that data set, those duplicate records. But in many cases, you'd delete those duplicate records majorly because they could be simply as a result of data collection errors. All right, so how we would delete those records is this particular data set, we would first of all load it, then determine the shape, then identify which observations are duplicates through the duplicated function. So and we would be able to identify. So in our data set, technically we don't have any particular duplicates within our data set. So we would not have any data set, so records. But if it happened that we had maybe hundreds, fine, they would be displayed here, but you wouldn't know how many. So what you would do is just use this function to know how many duplicates there are. So you would run that and it just tells us 0. If in this particular example, so we just found out that we did not have any records. What if we did? A good way of dropping the duplicates, not really a good way, but the only way that we would be able to do that by dropping those duplicates is through the use of drop duplicates function. And this is how we would be able to drop those particular duplicates, and by df.drop duplicates function. But in this case, this here, it would tell us, so it would show us which we would store the duplicates within the df duplicates variable. Okay, so in our case, we would also want to drop duplicates in a certain specific column. So in our height column, if we had 56 and another, let's say 56, I think we can be able to load the entire data frame because it's just 8, so that we see. So if we wanted to just drop similar values within this column, so like this one, 48 and 48, so it would drop, let's say, 1 centijoules. So this one would be the one that would be dropped. So if we wanted to drop that particular those particular records, first of all, what we would be able to do is to identify those particular records. This is Cindy Jules, this is the 48 one, and there's also another one, 62. So there's this one and also this one. So these two are repetitive. So these are the ones that we would need to deal with. So we have identified them. And remember, if there were many, we could have used the sum function to figure out how many there were, but our data set is small. So we could just drop them. And how we would be able to do that is to technically, first of all, we could be able to drop them through the use of drop duplicates, then hides. Then our unique data frame, the resulting data frame, would not contain those duplicates. So here we would have a shape of 2 less of our shape over here. So here, so it would be more of 8, 6 or 6, 8. 6, 8, 6 records and also columns. So rows or columns. So on that one, well, ideally, so we would have 2 less of the records that we would have. All right, let's go through the challenges and also the solutions, just to practice a bit of dealing with duplicate records. So in this video, we are going to go through the second last learning outcome, which is I can find and deal with missing data in a data set. Normally, when we have a data set, we usually our data set can have missing data, and that could be as a result of maybe the persons collecting the data might have forgotten to, or might have gotten to fill in the data itself. Maybe the data could have resulted from transfer of data, if some data is converted from one form to another through the use of different platforms. Sometimes that data can be missing, and how we need to when we're working with a data set, it's important to identify this, because missing data can also influence our models. If our model encounters missing data within our data set, then it would take that as a behavior that is evident within our data set, and whenever we give it input values, then it would, in certain cases, take into account, not even in certain cases, but it would take into account of the fact that there was some missing data within our data set, and our result or output would be also take into consideration of the missing data. And sometimes this missing data is not necessarily intentional. So we would be able to do that. How we would be able, first of all, to identify our missing data is to first of all find it. And how first of all we do that is, let's first, these examples are going to help us understand how that we would be able to do that. So let's first of all load our data set, or the data set that we've been working with. And as we can see, this NaN is not a number, it's ideally missing data. There could be lots of missing data, so we first of all go through a few methods. These are some of the methods that we can be able to identify whether our data set has missing data or not. So the first method checks for any missing values within our data frame. And as we had seen, this may not necessarily be that helpful, but it just tells us here there's missing data, here there's missing data. But what happens if we have 1,000 records? We won't be able to go through all the records to identify, like, which record has some missing data. So instead, there are other methods that could help us do the same. This other method is this one. This one is one of the other one, which, let's see what happens. It just also may not necessarily be the best. So this particular method would also help us to just identify which columns have or which don't have missing records. So these weight and account A columns do have missing records. So still, that doesn't tell us which are those particular records that we want. So let's move on to the other method that helps us to check how many missing values there are across each column. And when we run this, we should now be able to know, like, this weight particular column and account column have one value of one value, missing value. And sometimes you could have a column that has maybe 1,000 missing values, and during while preparing for that for analysis, you could just decide to drop the column because you know that column could have a greater effect on your analysis, so you just drop it. Let's see, there are other methods, by the way, which could also help us to also identify those missing values. And this particular method also just tells us that whether that particular data frame has it just tells us that this data frame, the entire data frame, has missing data. So maybe initially you may just want a shortcut. You'd be like, okay, I just want to figure out and see whether this data frame has missing data or not, and you don't want any further information, you just want to know that. But these method like this one just tells you exactly how many records there are missing within the columns. And lastly, we can also get a total count of the missing values within our data frame, and it can tell us that there are two missing values within that data frame. So far, I think the most valuable, the most valuable, they're all valuable, but the most effective one I would recommend is this one, because it actually gives you a breakdown of how many values are missing within the different columns. The next step we're going to do is deal with this missing data. So we could once we get the missing data, we could decide to drop all the records or the rows that have NA. So in our case here, we would drop this record and we would drop the other record that has it. We could do that. We could also decide to drop the columns if they we could also drop the columns if they contain missing values. So if the column that we had mentioned, if this column contains maybe more than 5 missing values and we were going to specify, then we could specify here, then, or like as you can see here. But this one is now this is majorly a record, but we could just put access to 0 to refer now to our column. So access is equals to 1 to refer to our column here. But now in our case, let's just go back here. What would happen is that we would in this case drop all columns which do not have any values. So if there's a column here and it doesn't have any value, then we can drop it, assuming there are even thousands. You could always a column that has all of them, no matter the number. So could always drop that column because it's not of any use. But we could also put a threshold in the number of values that column needs to have in order to to get deleted. If that column has more than 5 missing values, we could also do the same, but also we need to add this access to here so that in order to we can be able to delete that column. But in this other case here, we can drop rows in here. We can also drop rows, rows like these ones, which have, let's say, more than 5 missing values or 6, which is significant. We could always drop them because they're not of importance. They could not necessarily help us with our analysis. We could also decide to fill in those missing values with a certain value. So if it's none, we could also, if it's none here, we could also decide to put a 0 to just deal with that. This is how we can be able to deal to do that. We could see, as you can see, we've already put 0 0 whenever in that case. And lastly, we could also drop the missing observations. So could drop them, but like dropping is like you remove them so completely. So let me just load the dataset again with, of course, the missing values and drop them here, and you would see that they're all gone. The ones that are here. Okay, the last example, we could also decide to flag, and the flagging bit is just filling those values with 0 0 0, or you could say you could put whatever value that you would want to say. You flag that particular row, but you don't want to delete it, and you can do that by use of that, and it will just give the 0 and 0, and these two, whenever you come across a record that has these particular values, that these ones had missing values, so you may not necessarily take those ones into consideration. And while you're doing your analysis, you could always neglect these two values, but you would ideally be able to have access to your original data frame. Okay, let's go through the challenges and also now the solutions. All right, so finally we are going through our last session, and we will go through the following learning outcome. I can find and deal with outliers in a dataset. Going to a notebook, and we are going to first of all run the 2 prerequisites. We're going to need those 2 libraries. The first one is pandas, which we're going to use basically for data manipulation with data frames, and the second one is Seaborn, which we are going to use for identifying outliers. So our first example, it presents us with an example where we need to identify outliers within a data set. Basically an outlier is a data set that's way out of the norm of the others. By that I mean it could be a value that is way too high. It's not where any near close to the majority of the data records or data points that you have, so that could be regarded to as an outlier. Sometimes outliers happen due to natural causes. They could be, that's how the system behaves in certain cases, and that is something that you need to understand whether it's the case, but sometimes it may not be the case, so you need to say delete those records, because they could also impact on your analysis, and this is also evident in cases where you create models which are sensitive to outliers. So let's first of all load our dataset, which is this one, and once we load it, you can be able to see this is the dataset that we're going to be working with. Let's first of all just consider the year. We want to just work with the year 2007. So we are going to consider that particular only records which belong to 2007. Once we do that, we can now be able to, we haven't previewed it, but we could always preview .head those particular records. As you can see, 2007. Then we can now specify, from the multiple options of the, we're going to now use the box plot function with that is provided by the Seaborn library we're going to plot a box plot that will allow us to identify the outliers within our data set. So how we would do that is we would take two, say, variables. We would use, let's say, life expectancy and continent, and these are just a few. This is our data frame. This is just the width of our data frame and our box plot, and this is the color that we would use for a box plot. And this is how you'll be able to see how our box plot, it tells us that here in this particular record of life expectancy in Asia, there is some outliers. The same case in the Americas. At times this helps us to this method does help us to identify outliers, but it may not necessarily tell us like which ones exactly, but we'll come to that. So we could also continue to just sort of mark our box plot to provide us with the rest of the values where those values lie within. So as you can see, all our values lie within this particular range, which is it's more like it's well within a certain range of our box plot, which allows for those data points to not be outliers, but there's some of them which are extreme outliers which have been identified in our case. Okay, you can also remove these ones just to further style your box plot, which would appear as shown later onwards. If you need this particular visualization for analysis, you could export it. So the second example is, how do you now deal with these outliers? In this, there are many methods we could be able to deal with our outliers. The first method, the most common method, is using the interquartile range, and this is the first quantile, as you can see here, subtracted from the third quartile, and it's usually the middle 50% of the data. So anything that comes outside the 50% range of the data, then that would be regarded as an outlier. And mathematically, how we would be able to identify those particular variables or outliers is, first of all, say we could filter out. Let's say we would be able to first of all specify our quantile, and we can see then, which is 0.25 and 0.75. Then we would specify also, now this is our interquartile range, the Q1, the Q3 minus Q1, which is we are going to add as IQR, and that is going to give us the IQR for all the variables that we need, the variables that we have in our data set. And we can now filter our outliers by keeping only valid values. And say if we run this particular piece of code, this is going to help us filter out those outliers. So initially, while we were running our data set, if we just want to see let's see what was the shape of our data set. Then the shape of our data set was 1706. Then it dropped to 1387, which means that there are many outliers, and about could have been about 400 outliers which were removed from our data set and resulted to having this one, which has values which are within this interquartile range of the 50% range. So in this particular function, in this particular case, what we do is we can be able to specify the range that we would want to for this particular we would want to refer for this particular problem. Here if we wanted to understand what are these, if we wanted to get those outliers, we could be able to just remove that character, and we would be able to run this, and it would tell us 317 were our outliers. All right. Okay, so yeah, so now I think for now we can now go through the challenges and then go through the solutions, which would help us to understand how we can find and deal with outliers within our data set.